Alrighty, so questions?
How do you create an executable that you can share with your peers?
How do you create a what? Oh.
Executable?
Funny you should ask. So go into Eclipse, open up your project, and then you're going to go File, Export, and you're going to select a Runnable Jar File. And it'll ask you what configuration you want, and you need to tell it what the main program is. So here's my calculator program. I can run it from Eclipse, and it looks like that. So I'm going to right click, I'm going to say Export, and under Java I'm going to say Runnable Jar File as opposed to just plain jar file. And if you have multiple projects, right, you want to find the one that corresponds to your project, and in this case it's a class called main, right? That's my main class. Apparently my main class for all my projects. So pick that and browse to where you want to place it. Let's just place it on the desktop, and I'm just going to call it haha.jar and say finish, and you'll usually get some warnings, and you can look at them if you want, but they're usually just warnings. And that's all you need to do, so you can close that out. And now if you go to wherever you exported it, there's my haha.jar. So you can execute it by saying java-jar haha.jar, and that just goes ahead and runs it.
And this can be uploaded to Canvas and shared.
It could be uploaded to Canvas and shared.
Okay.
If it'll let you upload jar files. I don't know, sometimes they get blocked because they contain code that you can execute. But I mean, you can execute anything, but some uploads block that. So what is a jar file? A jar is like a tar, but it's made for Java. It's a Java tar file. But it's actually just a zip file. But it's expected to have this manifest inside that describes the classes. And it's a collection of classes, right? So these are all the different classes that went into my my calculator, right? Including things that you imported and so on and so forth, perhaps. So it doesn't have source code in it. Anybody else need the sign-in sheet? All right, in the back. And if you think about when we run main class, a class containing a public static void main, usually we have a directory that has all of the classes that we need in it. So my main class needs the rectangle class, and that's sitting in the directory. But that's not required. You could have some of these classes sitting in other directories, and you can specify where those are when you say Java main. You can use a switch that says class path, and you can list other directories that contain classes that you might need. And if you need many class files from many different directories, you can have a bunch of class path statements, right, naming all the different locations that it should look for classes. But another option is to take all of those and bundle them into a jar, a Java archive. And then you can just, when you say Java main, you can specify that jar file as part of the search path for classes, and it'll look in there for classes. We don't have to deal with this right now because when we've been on the command line, we've had everything in one directory, and when we're in Eclipse, it will take care of all this for us. But at some point before we're done, we'll probably play around with this, and this will get us into looking at packages. And these are all ways that we can organize this notion of different classes in a reasonable way, so that you don't have to have 25 class files every time that you export your project or something. So there's lots of niceties in there. All right, other questions? So we played a little with try-catch blocks in class this morning. And this was related to one of the quizzes that is posted is on try-catch blocks. So just made some sample code to explore try-catch and also to look at this notion of a finally block. So I've got two integers I and j. I'm going to divide them inside a try block. If an exception occurs, I should jump down to my catch block, which will say inside catch block. And this finally block is a block of code that's always executed. Whether you make it all the way through the try block or you get part way through the try block, an exception occurs and you jump into your catch block. When you're done with either of those, it will go off and it will execute the finally block. And so in this case, I'm going to say when we get into the try block, we'll do our division. If we get an exception, we'll say we're in the catch block and see what the exception is. When we get to the finally block, we'll say that. And when we're completely done with the whole try catch finally block, which happens right here, right? So when we get out of that, then we'll have a message saying we're outside of all of that. And so right now it started in the try block. It succeeded in doing I over j because j was equal to 1. It went to the finally block and then it ended up outside. Now if j were equal to 0, so we'll be doing a division by 0 here. With integers, that's going to throw an exception. So we started off in the try block, we jumped into the catch block, and that was our exception, Java language arithmetic exception, division by 0. And then we still went to the finally block, and then we were finally outside. So here's the weird thing. In my catch block, I'm going to print out the message about to return, and then I'm going to execute a return statement. And this is going to do something slightly weird.
Either exits the program or exits the catch.
Good question. Kind of neither. So we're inside the try block, we're trying to do division, we jump into the catch block, we print the exception. It says about to return, but then it says in the finally part, and then it apparently returns before it gets outside the try catch block. So this is a little weird. The flow is we started off up here, we came in here, we did the division, caused an exception, it jumped down to here, jumped down to here, but then before it returned, it came down to the finally block, and then it came back and did the return. It's a little strange.
It's somehow smart enough to catch the return.
Yeah, so if there's something that you want to do, regardless of whether you're in the try or catch block, but you want to sort of buffer up a return in the bank, right, you can use the finally block to do something, and it will do that before it actually exits from the try catch. But the return will absolutely take you out of this method before it gets down to, say, this print line.
That would have been super frustrating to figure out.
Yeah, and I mean, I get what it does. To me, it's alien. I've never used this, but I'm sure there's good uses for it. I've actually just never used a finally block, but maybe I will someday now that I know what it does. But I didn't know that till I started teaching this course. There's a lot of things I never knew till I started teaching 224, 22, 23. So, all right, so that's just a little blurb on try catch finally, and that code is up on the server. All right, I want to look at linked lists some more. And I have a rectangle class that I wrote this morning. So it's got a height and a width, it's got a constructor that takes a height and a width, and it's got a toString method that just returns the string height by width. So pretty basic rectangle class, everything accessible. So let's play with linked lists. So something else I mentioned this morning, we're in a Unix environment, right? Even if you're using Eclipse, you're possibly still using a Unix environment for your laptop, right? Or if you're on the server, you're generally in a bash shell. We can tailor this environment however we like. We can do things to make our life easier. And I've got things that I've done over the years that sometimes you see me doing up here. So here's a new one that that I wrote during breakfast yesterday. I keep making a file called main.java, and it's class main, curly bracket, public static void, little main, parentheses, string bracket, bracket, args, more curly brackets, and closing curly brackets. I type that like, multiple times per day per class. And I got tired of typing it. So so I can say init, and it'll make me a main.java, right, which has all of that stuff in it. And that's kind of cool. And that's really just, I have this main default.java sitting in my 223 directory, and I just copy it when I want a new main.java. But I can also say init haha.java, and it'll make me a haha.java, and in there it says class haha, right? So it doesn't have to be called main, and I can actually say just init haha, and it'll still make a haha.java, so it will add on the .java if needed. And if I try to init something that already exists, it won't overwrite it. It'll tell me I've already got a file by that name. So I can't accidentally clobber some precious piece of code because I'm in the wrong directory. And init is just an alias to a file called doinit. And doinit is just a bash script. There's nothing fancy or very technical going on in here. Fname is the name of the file I'm trying to create. If I don't put an argument on my command, I'm just going to use main.java. But if I have an argument, if $1 is not blank, then I just set my file name, fname, to whatever that argument was. So it could be main.java because I didn't specify. It could be haha.java. It could be haha. So now I see if there's an extension given. So I echo that. I put it into grep, and I search for the pattern period java followed by the end of the line. That tells me if I typed in something that ends with .java. I throw the output to dev null so I don't have to see it, but I check the return status from grep, $? And if it's equal to 1, it didn't find a .java, so I tack it onto the end of fname. So now fname is nicely conditioned. Next thing, see if it exists. So -e returns true if the file name exists. If it does, I tell you it exists and I exit. Otherwise, I'm going to go ahead and create a section of code. So if the file name is exactly main.java, I just copy my template file into fname and we're done. Otherwise, I take the file name, I put it through sed, and I replace the .java at the end of it with nothing, right? So I get rid of the extension, so now this is the name of the class. And then I cat that template file, but I substitute the uppercase main with that class name, and I save it in fname. And then I just print a message saying it was created. Now that, took me 2 pancakes, I think, to write. And it's not going to change the world, okay? It's not going to add 50 years to my life, but it saves me a little bit of typing, it saves me a little bit of distraction, you know, and if I really, really need to write a piece of Java code super quickly and I've only got a few seconds, right, this will save me a lot of the time I have. I can just say init and I got a main.java and I can go from there. But also, it gave me a chance to brush up on some bash, right, because I got to review and relearn bash every fall so I can teach it. So, you know, it keeps my bash skills current. But it just makes the environment a little bit more mine, right? And the more comfortable you are in an environment, the more it's going to feel good working there and the more productive you're going to be, right? And there's tons of things you can do like this. If I have a directory called backup, uppercase letters, sitting anywhere in my system, I can type the command backup and it creates a backup of all the files in my current directory. So I can say backup again and I've got a new copy. Now if I look in this backup directory, I've got two subdirectories and they're date stamped and time stamped. And if I look inside each of those, it's got a copy of all my code. It's a really quick and dirty way to back up your code just in case you happen to do something like, let's remove everything. Oh dang, I lost my files, right? Well, I got them in the backups. And you've got, you know, the latest version anytime that you said backup, but anytime you say backup, you get a new copy. So now I got 3 backup directories and one of them is empty. But I can pick up this one. Right, now I got my code back. And backup is just an alias to one line of bash code with 3 pieces to it. Right, find the date in that format, so that's the date, hours, minutes, and seconds with an underscore, and I set x equal to that. And then make a directory in the backup area called whatever x is, and then copy everything into that directory. So again, it's not like brilliant or anything, but it's a quick one-off, and if I'm working on something and I don't feel like pushing it over to Git, I can always just say backup. And you know, I got a feeling the cat's about to jump on the keyboard and hit RM-RF star, and I can just say backup, and you know. So keep in mind, you know, how you can take advantage of the environment you're in. Other operating systems, you can't necessarily do things like this. You got to learn their way to do things, and sometimes it's very complex to do certain things. And if you're on Unix, you can customize everything, more or less. And a lot of it doesn't take too much work. And all of these aliases, right, you can put them in your bash RC and create all these aliases. So when I say doc something, it's running a file called doc that I have. It's another bash script. If I don't want to type cheese, I can type cam1 because it's easier to remember than cheese, but now I remember cheese. So. Alright, so for whatever that's worth. So let's play with rectangles. So we'll go with main.java after all that. And we're going to use the linked list class. So linked list comes from java.utility. And we looked at this a little bit yesterday, right? So we can add to the end of the list, we can store things at a particular location, and we can search for things and clear the list and so on and so forth. So let's play with this. And remember, these are generic, so we're going to put in angle brackets the type of thing that we want to use. But let's make a linked list of rectangles. So list 1 is going to be a new linked list of rectangles. List 2 I'm just going to declare as a linked list of rectangles, but I'm not going to construct it. Okay, and we're going to create some rectiles. Rectiles? That should be a thing.
What would they look like? I wonder.
I'm sure they would have teeth, and they'd be green. Alright, so I'm going to add some things to the end of the list. So list1.add new rectangle, and I'm going to be unimaginative and just make a bunch of squares, and they're going to increase in size. So there's 5 increasingly large rectangles we're going to add to our list. And then let's just print it out with print line and see what we get. So we'll concatenate it as a string to list1 equals, and we'll run with that. You ready? Boom. There's a nice display of our linked list. So we saw yesterday if we do this with integers, we get a comma-separated list of integers inside square brackets. If we do it with something other than an integer, it uses the toString method in that object to print out a comma-separated list of your objects. And since there's a toString in rectangle that prints these things, that's what our linked list looks like. So this is highly usable already. And we really didn't write a whole bunch of code. Alright, well, we've got a linked list object called list2. Let's set list2 equal to list1 and print out our 2 lists. And much as we would hope for, list2 looks exactly like list1. It's a linked list with 5 rectangles increasing size. No big surprises or worries there. Alright, let's remove the third element from list 2. So there is a remove method on lists. We can say remove and put in the index of an element we want to take out of the list. Third element will have index 2 because we start from index 0. So I'm going to say list2 dot remove 3. 2. And then let's print out our lists. And so what happened here that we may or may not have expected?
It skips. It did exactly what we would have done in a linked list, which is register the next node as the next.
Right. But what list did we remove it from?
Only one.
Only from list 2, but what happened to list 1? That third node disappeared from that list also.
Interesting.
So is the copy just addressing to list 1, or is it?
So the copy is really just addressing list 1. When we said list 2 equals list 1, here's the picture. Here's a picture. There's our list. When we said list 1 equal to a rectangle, think of it almost as a pointer, right? List 1 is basically referring to this list it's got some location in the Java Virtual Machine's memory. List 1 is basically pointing to that. It's an address in memory. So when we say list 2 equals list 1, list 2 is pointing to exactly the same thing. And anything you do to list 2 happens to list 1 and vice versa.
This is true for like any object, right?
This is true for any object.
Anytime that you're making something, you're referencing something to someone else. If you aren't using new, that object's not unique. It's being
Exactly.
used in multiple places.
Yep, exactly. And this is also why, say, using double equal on strings usually doesn't work. Because it's saying, is this string and that string, are they referring to the same object? Not, are they the same letter by letter? Right? So this is a kind of subtle but fairly important concept. That these things, even though we don't talk about pointers in Java, they're basically pointers to objects. They're references to objects. And saying list 2 equals list 1 just makes list 2 refer to the same object as list 1. Okay, so let's use this clone method. So let's get rid of this remove third element from list 2. Actually, let's just move it. All right. So what are we doing here? We make a list 1, we add 5 rectangles to it. If we set list 2 equal to that, they're going to look exactly the same. We're not going to do this, though. What we're going to do is we're going to set list 2 to be a clone of list 1. We'll print out the 2 lists, and then we're going to remove the third element from list 2 and print out the 2 lists. And this will do something different this time.
Sounds like it will malloc.
Sounds like it will fail to compile. So clone, if you look at the description of it, it returns an object. Right? Why does it return an object? Because it doesn't know that I happen to want to return a rectangle. If it returned a rectangle, it would be useless to most people. So it returns an object, which is the most general type of object. That's why it's called an object. Right? But we can cast an object to a rectangle by putting a rectangle in parentheses, or to a linked list of rectangles by putting linked list of rectangles in parentheses. So casting is a trick that we do basically to appease the compiler, right? To basically say, yeah, I know you want a double here. I've got an integer, but it's okay. Just turn it into a double, right? Or I know you want a double here, and I've got an integer, or you want an integer and I've got a double, just go ahead and convert it. Just round it off or something, right? So what we can do is we can say linked list of rectangle. In parentheses, that means take list 1, clone it, that gives us an object. Now cast that to a linked list of rectangles, and now set list 2 equal to that, and it'll be mostly happy since list 2 is a linked list of rectangles. This will give us one of those weird lint warnings. And I need to run this down and figure out how to not have an unchecked cast. There's something we should be doing here. But it will work anyway to compile it. And go ahead and run it, and now we got something more like what we wanted. We have 2 lists. We removed the third element from list 2. List 1 was unaffected.
Is it because our list is a linked list, but the objects within the linked list are rectangles? So there's no way for clone to know that it wants to create a linked list with rectangles as the object argument.
Basically, yeah.
So that's what error we're getting, right?
Yeah, I mean, It's almost like a language issue, because it's just returning a reference to something, right? And a reference to a linked list, a reference to a rectangle, a reference to an object. It should still just kind of be a reference. It's like a memory pointer, right? But if you return a pointer to a struct rectangle and it's expecting a pointer to a struct node, you'll get warnings from the compiler, right? Not that it can't do that, because it's still just a memory address, but it wants to make sure that you specifically say turn this into this other kind of reference. And I think that's all that's going on with this. So we have separate lists now. So here's what this looks like. So list 2 is referring to this list, and it's a completely separate list. So if we remove element 2 from list 2, we do this. It has no effect on list 1. So cloning is helpful if you want to duplicate an object, a data structure, and do things with it without affecting the original. But it's not completely perfect. So if you look at clone, it says returns a shallow copy of this linked list. So shallow copy versus deep copy is our last concept related to this. So we've got list 2, it's totally separate from list 1. So I'm going to do the following. I can get an object with get, right? I can say get index, or I can say get last. So let's try this.
What's the difference between a shallow copy and deep copy?
We are about to see. So let's change the dimensions of the last rectangle in list 2. So I'm going to say list2.getLast, which gets me a rectangle. And I'm going to set the height equal to 99. I'm going to do list2.getLast.width, and I'm going to set that equal to 99. I'm brazenly ignoring the ideas of setters and getters and just going in there and pushing these things around. And then we're going to print out list 1 and list 2.
I have a hypothesis here.
Okay, what's your hypothesis?
When you tell it to clone, it's taking a snapshot of memory at that point. And so if you're changing the dimensions later physically in memory, it won't know, because all it has is a snapshot of what memory looked like, not what it actually is.
That would be pretty cool.
But is that not what it does?
But that's not what it does.
It won't do anything?
It will change the dimensions at the end of both lists.
Because it's shallow.
Because it's shallow. So what does this mean? So we need a nicer picture now. So here's list 1. Here's list 2. And we deleted something from list 2. Well, we created a 1x1 rectangle and a 2x2 and a 3x3 and a 4x4 and a 5x5. And when we created this first list 1, what did we do? We said list1.add new rectangle 1, 1. So when we say new rectangle 1, 1, we create this 1x1 rectangle. It's an object. When we add it to the list, we're basically saying that the data portion is a reference to that. And in this node, the data portion is a reference to that, and so on. When we said list2 equals list1.clone, it created a linked list. It's got its own set of nodes. So we're not dealing with the nodes in list1 at all, but the data portion is copied verbatim from list1. So even though these are separate lists, and even though we have a separate node here from here, those are not the same object. What they refer to is the same 5 by 5 rectangle. So if I grab this rectangle and I change it to 99 by 99, then when I print out list 1, the last rectangle is 99 by 99. So that's the consequence of a shallow copy. We're not cloning all the way down the tree, and that's really hard to do in general because you have to understand the data structure. You have to know that this rectangle has simple integers, or maybe it has fractions for its sides. And we have to go through and we have to copy the top and bottom of each fraction from our fraction class. So shallow copy is easy, it's just kind of one level down. If you want a deep copy, you often have to write that yourself. And it's based on your understanding of the types of objects involved. And this can show up in all kinds of subtle and potentially disturbing ways. So let's copy list 1's last element to the start of list 1. So how are we going to do this? We're going to say add first. So list1 dot add first. And what we're going to add is the last element, which we can get from get last. Alright, so list 1, call the getLast method, that gives us the last node, and then we pass that to the addFirst method. So whatever is at the end of list 1 should pop up in the beginning of it. And we're going to go ahead and print that out. And then we're going to do our trick again where we change the last element in list 2. And you can probably guess where I'm going with this.
It's going to look like a mess.
It's going to look like a mess, but it's a beautiful mess. So this pair of lines right here came from taking the last element in list 1 and inserting it in the beginning. And then by changing the last element in list 2, we changed 2 elements in list 1. Why? Because when we took this node and copied it to the beginning, it was the 5 by 5 rectangle. It was this box right here. We said insert that in the beginning. It created a new node that was also referring to that 5 by 5. And this can happen a lot, and sometimes it's perfectly fine. Sometimes it's exactly what you want to have happen. But sometimes it's just something you didn't really think about. And you can start getting some crazy looking behavior in your code if you've got one object that you think is 3 or 4 or 100 different objects. And if you're aware that this is a thing, it can help you sort of think about whether this is going on. So it's just something to keep in the back of your mind. It's almost certainly not going to come up in this course, but it's something that sooner or later will probably come up and try to bite you. And when it does, it's just kind of drawing pictures and thinking about it, or using the debugger, and just knowing that it's a possibility helps with thinking about it at the right time.
Then when we want to use a clone.
Say again?
Then when we want to use a clone.
We don't care about our original list anymore.
Well, I mean, if I'm never going to change rectangles, let's just say I have a linked list of rectangles and, I don't know, I want to make a new list that I also add some other information to the nodes. But I'm not planning to actually go in and do something kind of bizarre like this stuff right here. Right, if I know those objects are, to me, immutable, or maybe they are immutable, right, this is perfectly fine. If I have a linked list of integers where I've got primitives, right, then this is not going to come up and not going to change what the number 5 is equal to. And so a shallow copy is essentially a perfect copy of a linked list of primitives. Or if it's got strings and I'm not going to change the strings, I might just add and delete nodes. That's going to work perfectly fine. So I don't know, maybe you're making a game and you start off with a list of items that the person begins with, and every player starts with the same items, and so you have a master list and you just keep cloning it for each player, and now if somebody discards an item, you can remove it from their list. That's going to be perfectly safe. But what you wouldn't want to do is say, player 2 list equals player master list, right? Because if every player is actually referring to the same list, when you delete an item from one player's list of inventory items, it's going to get deleted from everyone. So you definitely need a clone or a copy of some kind in that case. But it may not have to be a deep copy. Alright, so that code is in shallow deep copy, or a version of that code. So other questions about that? Alright, so before I forget, tomorrow's going to be an open lab for class. So come by if you want to work on stuff, and so on. And then Friday I want to start talking about hashes. So we're going to look at hash maps, which is one implementation of a hash. And a hash map is a generic class, and remember, hashes, basically they're associative arrays. So we have a key which we use to access a piece of information, which we think of as a piece of data or a value. And so K and V are the key and value, and they can be any type of object. And so it's a generic with two parameters specifying the type of the key and the type of the value. So when you construct and so on, you use angle brackets, string comma string if you want strings to be used to index strings or whatever. And once we create a hash map, we can do all the usual things that we want to do. We can clear all the entries from it. We can clone, right, shallow copy. We can retrieve an object by its key. We can put a value in associated to a key. We can remove an object by its key, and so on and so forth. So add, remove, search, and good things like that. We can also do something called key set, which will give us a set. A set is kind of like, could be an array, could be a linked list. It's just a set, an unordered collection of things. In this case, key set returns an unordered collection of keys associated with this hash. And if we look at a set, sets have a method called iterator. And iterator will return an iterator over the elements of this set. What does that mean? Well, if you look at an iterator, it's a thing that has a hasNext and a next method. And we can use those just like we do with scanners to access the things in that set. In this case, the keys in our hash one at a time. And so we can make a loop. Well, iterator.hasNext, next key equals next paren, and the next key will be the next key from our hash table. No particular guaranteed order, but it's a way to write code that grabs your keys one at a time. And there's other ways we can do that. We can turn those keys into a collection and pull them off inside a for loop and so on. But sometimes using an iterator structure, has next and next, is more convenient. And so we'll play around with all of that, and we'll see how to do some of the basic operations with hashes.
Did you say V is the map?
V is the value, and K is the key, the thing that we're using to access the value. So for example, K could be the person's name, and V could be their integer ID number or something. So we construct a hash map, angle brackets, string, comma, integer, or whatever types of objects you want to use.
Okay.
So if you want to dust off your notes on hashes, that may be useful, because that's mostly what we'll be working with. So we'll do that on Friday. Again, tomorrow's open lab. All right, good to go? You're out of here 15 seconds early. All right, I'll see you tomorrow.